Hey everyone, welcome back. This is the part 2 of the WebRTC introduction. So I wanted to show you a small application which will implement the WebRTC to share the screen and the audio between two peers. But I decided to explain you more about the signaling process and also about the RTC peer connection interface, which is API that is needed to build the connection, to establish the connection between the two peers. So in the next part, I will try to build with you a small application from the ground up. But in this one, let's get a little bit more familiar with the concepts that we are going to use in the part 3. So without further ado, let's go ahead and take a look what are prepared for this one. So in this part, I will talk about the signaling process and the RTCPeerConnection API. So at this diagram, you can see I basically draw a process of the signaling. So in order to establish the connection between two peers, we have to create, or we need a signaling service or a signaling channel which will exchange the information about the two peers, their network information, the media type, the format of the media, and all the information that are needed to establish the data flow between the two peers. And so in order to do that, the peer number one will have to create an offer, which basically is a proposal of the configuration to establish the bidirectional data between the two peers. So the peer number one creates the offer, which holds the information about the peer number one, the media type, the format of the media, and also the IP address, the network port that is being used. And so this offer, which holds all this configuration, it's sent to our signaling service, which is in this example is a WebSocket, and the WebSocket will send it forward to the peer number two. The peer number two, when receives the offer, it stores as a remote object, as a remote description. It would then create an answer which will hold all the configuration of the peer number two, so the same as the peer number one. So it will hold the media type, the format of the media, the API address, the port, and so on. And so it will send the answer to the signaling service, which will then send it forward to the peer number one, right? And so this is the big overview about the signaling process, which is needed to exchange the data to get an agreed on which configuration the two peers will open the connection, right? And so before I get deeper in the process, I wanted to explain you the RTCPeerConnection API. So this is the API which provides us with the methods we can use to create an object which will store the data. It will also create for us all the needed information that we have to exchange between the two peers. And so the first step that we have to take is to access the user media. And we can do it by accessing the navigator of the browser, then the media devices that are accessible on the browser, on the device. Then we can access the get user method, pass all the media that we want to get from the user. And so in this example, I wanted to get the video and the audio from the user. And so after that, we'll get a promise with the stream, which I'll store it as a local stream in the browser. So the next step is to create the RTCPeerConnection object. And so here you can see that I'm creating an PC value, and I'm calling the RTCPeerConnection constructor function, which will create for my new RTCPeerConnection object. And after that, I'm just passing the stream media that I'm getting back in the promise from the navigator. And so here you can see that I'm passing our RTCPeerConnection object, and I'm calling the method at the track. And then on the stream, because I'm accessing the both streams, so I'm accessing the video and the audio media types from the browser, I have to specify it. So here I'm calling the first one, which will be the audio, and the second one, which will be the video. So this way we can add the tracks, the media tracks to our object, which will send them to the peer number 2, right? So the first step, we get the media. The second step is to create the object, add the media type or the media tracks to this object. And after that, we can basically create the offer, which will then send it to the peer number 2. And before we're gonna do it, we have to create also an event listener for an ICE candidate. The ICE candidate, the ICE acronym stands for Internet Connection Establishment. And what it is, basically, it is an object then that describes the network that you used to connect to the peer. And this object will be created for you internally, so you don't have to create it by your own, but you have to set an event listener for this object. So before I'm creating an offer which will hold the ICE candidate and the other information, I'm creating this event listener which will emit this candidate to the peer number 2. And for example, the type, this is optional, the type is optional, so we can omit it, but I'm sending the type of the candidate with a label. On this event, we can access the event candidate, SDP, and line index, which I'll not explain because this is not the information that you, if you're interested, you can look it up on the internet, but I thought that this not necessary to basically build our application. And then we can send the ID, which again I'm accessing on the event, and then candidate, and then SDP meet, and then candidate, which is basically on the event object, and candidate, and then candidate. So the first step, again, when I'm getting this candidate, I'm sending it to the peer number 2, and then I'm creating the offer, which will then give the promise back with the session description, which I then set as a local description. So when we create the offer, the RTCPeerConnection will create for us the description, which we will also have to store it locally before sending to the peer number 2 inside the offer. All right, so here again, I'm setting this as a local description, and after that, I'm emitting this with a socket as a type of the offer, and then the SDP, which again stored is an acronym for the session description protocol, and this is the protocol which basically is it enable us enable the exchange of the data. So this protocol is needed to exchange the session description information. All right. So we have our media. We added this media to the RTCPeerConnection object. We then also create the offer. We store it as local description. And so after that, when the peer number 2 receives the offer, it will then respond with the answer. And so the answer will be its local session description of the peer number 2, right? So here you can see that I have an socket event listener which will listen for the offer. And whenever the offer gets in, we then create the connection, the RTCPeerConnection object, the same way I'm creating it here. So the same here, you can see I'll have to create it here. Then I will have to add the media tracks the same way I'm doing it here in the step number 2. And then after that, I have to set this description as the remote description of the color of the peer number 1. So I've created the object, I've added the media tracks, I've then I've created the remote description, and I'm passing in the new RTC session description, and as an argument the description that is passed from the peer number 1. And then I'm creating the answer, which will give us the promise with the session description, which is the local description of our media type, the media format, the IP address, the port, and so on. And when the peer number 1 receives the answer, it will then again do the same steps as the peer number 2. So it will store it as a remote session description. It will then add the media. So here you can see basically I'm just adding an event listener on track. So whenever it will get a track of the media, it will then store it as a remote stream. So here you can see I'm just accessing the event, and on this event I'm accessing the stream object, and I'm setting it as a stream media. And as on this last line, I'm setting the remote description in the same way I did it in the step number 4. So here I'm accessing the RTCPeerConnection object, and I'm setting the remote description. And when the peer number 1 saves the description of the peer number 2, the data begins to flow, right? So let's take a look one more time at this signaling diagram. So again, the peer number 1 creates the offer. It will store it. It stores all the information that is needed to establish the data between the 2 peers, sending to the WebSocket. The WebSocket sending forward. The peer number 2 stored the offer as a remote description. It will then create its own description, which contains the same information that are needed for the connection, send it forward to the WebSocket, and the WebSocket send it again to the peer number 1. So this is the process of the signaling, which is again the initial process that is needed to make the connection between the 2 peers. And so in the next part, I will show you some small application. We'll try to build it from the ground up, and so I hope that you will enjoy it. If you have any questions, then put them in the comment section, and I will see you next time.